Okay, yesterday, this is where we left off. You remember from yesterday?
Yeah.
And so I want you to go ahead and do this one right here. See if you can play with 7 and 8. And we'll go over what they are. Again, you have a calculator. I hope to help you out, help you kind of check. A lot of people are anti-calculator for instructional purposes. But I am not if the calculator is used properly. What's a proper way to use a calculator on a problem like this?
She said she can't do anything for me.
What's a proper way to use a calculator on this problem? Or what the best way, I guess.
Find a solution.
Okay, here's the best way. You try to work it out without a calculator first, and then use your calculator to check. That's the best way to do it. By the way, you know what kind of function this is here? You ever seen a function like that before?
Isn't it like the absolute value?
The absolute value function. Did you go over that in Algebra 1? You did? Okay. Yes, that's what this is exactly. Okay, what does a horizontal compression by a factor of 1/3 look like, you think?
Wider.
You think it's wider?
Yeah.
So horizontal compression would be a widening? No?
I thought it compression.
Compression is smaller, but 1/3.
Oh, so 1/3 is confusing you?
Yeah.
Oh, it's
Yeah.
compressed.
Well, here's the thing about it is compression, if you're compressing horizontally, it's going to go like that, right?
Yeah.
Right. But do you know how to draw that? Would you know how to draw that? Anybody have an idea how to draw that? Okay. Well, what happens is, it has to do kind of with, let Mark get to Marcus's. What happens is, if you 1/3, like you have this, and you know you're going to have to go this way, right? You're going to have to bring this one in and bring this one in, right? And so what is the slope of this line, this ray here, emanating from the origin? What is the slope of that? 1, right? And a slope of 1/3 would be like this, right? And is that what confused you there, Siggy? Okay. But we know it's going to have to be this way, so logically, what is this going to have to be over here?
2/3. That'd be 3.
Yeah, it's going to be like this,
Yeah.
right? It's going to be a slope of 3, essentially, from here. So it's going to go like this. And I'm going to show you how to put that in the calculator in a minute. Okay, but we're going to let Brindy tell us how to do that, if she remembers how to do that in the calculator. Okay? So that's what it's going to look like. And so how did you write this? G of x equals f of 1/3 x. Okay? Yeah, that's it.
Go, Marcus.
Yeah. And
You don't like
I want to go ahead and put this in a calculator too. Okay. Does who knows how to put absolute value in a calculator? Does anybody know how to do that? There are different ways to do it, but I'll show you the quick keystroke way, the best way I know how. What you do is you press second and then the catalog key. And then it just, out of coincidence, absolute value is the first thing in the alphabet. So you press enter and that's what you have.
Where's the catalog?
Oh, there it is. It's on 0, guys.
Yeah, and then what you can do is you can take, and we'll see if Marcus is right. You think Marcus was right?
Yeah.
So we're gonna see what this looks like. Absolutely. Absolutely. So we go here at x, right? And so we graph the thing. Okay, Marcus. This is your moment of truth. Marcus's moment of truth.
Oh, oh, how do I reset my,
Enter. I'm entering.
Such an
like that? They can do it on both sides. It's definitely not right, Marcus.
Am I wrong?
Is it
It's 3x.
3x?
It's 3x.
Yeah, it's gonna be free. Let's do that.
Okay.
Yeah, it's gonna be great. There's no.
We said how to write the first one?
So 3. We'll try this now.
That calculator.
Okay, so yeah, and so what it is, this is one of these deals where a vertical stretch is the same as a horizontal compression, essentially, is what it amounts to. And what you're doing, here, let me tell you what it is, okay? The way this is, I'm going to do it in the language of this here. If we take this fraction here, I'm going to make another fraction. And what we're going to do is we're going to take, and I'm going to get rid of this 3 over here. What we're doing is we're taking 1, and to compress horizontally by a factor of 1/3, what we would do is we would take 1 and divide it by 1/3. Okay, that's what would do the thing. So what's 1 divided by 1/3? It's
3.
Okay, it's 3. Okay, so so in the technical language of that, it's 3. But I would just go ahead. So 1 divided by 1/3, or you can just write 3 f of x, or it would come out the same 3 f of x, or f of 3x, the same way either way. Okay, so it's kind of tricky, so I just recommend experimenting. No harm done. Okay, compress the graph of f of x horizontally by a factor of 1/2. What is that going to look like?
It's gonna be,
Be wider, right? So this is the slope of 1 again. So what slope are we looking for here?
2. No.
Probably 1/2, right? And so it's going to be g of x equals, how would you do this? Did anybody experiment with their calculator yet? Or just,
1/2 of the.
What do you think? Jose, what do you think?
Wrong.
One half x, you think?
Yeah.
1/2 f of x? And the way Haley mentioned it, this is the way I would do it, because I like to just multiply by the outside if I can. And so you could write it like this, or you could just say, how could you write that instead? I guess you could say like 0.5x, something like that. 0.5 absolute value. Is that how you do it? Let's do that. 0.5 absolute value of x. See if this looks right. I think it should look right. Yeah, that does, right? Slope of 1/2. Okay. All right, very good. So these would be our answers, I guess. See, I like making them all vertical compressions like this. So you take this horizontal compression, I like making it a vertical stretch instead. That's the way I like to do it. It just, I think, to me makes more sense, makes things more consistent. Okay, this one here, you're going to reflect it across the y-axis. And you reflect the graph of f of x about the axis. So do those. See what you get. Walk around and look here a little bit.
I don't know how to do the model.
Lord.
Did you do this? Huh? Yeah. Negative.
And Doug, I want to ask you something here. Did anybody use that little chart we took down notes on yesterday for this thing? Did it help you?
Yes.
Good. All right, good. All right, I'll tell you what I saw, and what happened. I saw people had different ways of doing this. I saw some people who first, and this is the way I did it, the first thing I did when I did this problem is I went and made the sketch of it like this, right? I actually sketched it first. And then after I sketched it, I wrote what g of x is. And what what is g of x equal to? F of negative x. And this is right from the chart notes we took yesterday, right? Good work. Application, that's application. And then this one here, this one here is going to go like this, right? And so for this one, g of x is equal to, I had like negative f of x, right? Is that what you got? Okay. That's what you got, Jose? All right. Good. Now, to me, really, other than the left and right shift, to me, what we're doing in graphical transformations, to me, it seems like it's one of the easiest parts of the course we do this year. It really is. And I mean, it's so much so that we do the same thing in pre-calculus and don't even spend a whole lot of time. Okay, this one here, reflect across the y-axis.
Can I have your attendance sheet, please?
Are you wrong? Mark likes boys. He likes boys. Let me get the other one too. Oh, I gotta do it.
Why is this really? It's not.
All right. All right, this one here, reflect across the y-axis. What is the reflection across the y-axis going to be? G of x is equal to f of negative x. Okay, so that's going to look something like this, right? Something like that. Let me do it a little better. It's going to be to 3. It's going to be like this. That's a little better looking, okay? And then this one across the x-axis is going to be g of x is equal to negative f of x. Okay, so it's going to be like, again, 3. Something like this. Rotate about the x-axis. Rotate about the y-axis. Okay, so we're done with this one here today. I want you to go to the next sheet, which is problem 13. Can you do that? Let me go ahead and erase these so I get ready for the next class. Alrighty, okay. Okay, the next one here really talks about to determine if each function is an even function, an odd function, or neither. And so I think, did we talk about that? We talked about that in section 1.1. Yeah, we did. What does an even function do? Remember, just look at, for instance, problem number, well, look at it. Remember the definition for an even function? I'll tell you what it is. Even actually, we did that more in pre-calculus. Even function, what it is f of x, or f of negative x, is equal to f of x. That's the definition of an even function. An odd function has another definition. And it's f of, or negative f of x no, I gotta say it differently. F of negative x equals negative f of x. So these would be the two different algebraic definitions of odd and even functions. But these definitions here are what I call academic definition. You know what an academic definition is? It's something you read out of a textbook where whoever wrote it kind of a dry, like a very high language, and sort of like, you understand what I'm trying to say?
Yeah.
It's kind of hard to understand, maybe. Not in common language, academic language. Okay, I want to go ahead and translate these into like common, what this really is. Okay, even function, this is what this thing here means. Does anybody know what it means first before I write it down, what it is in plain English? Okay, yes, so Randy got it right. So reflects about y-axis. That's what this is. Okay, so if you see a function that reflects upon itself on the y-axis, that's an even function. So what do we have an even function up here? So this would be it, right? Even. Okay, Randy gave us the plain explanation of what about for an odd function? What is that? Pardon me? No, it's not that. Okay. What'd you say? Kind of. Now they say what they say. They say it has it reflects about the origin. I don't like saying because to me that doesn't make sense, because what about the origin? What this really means, this has what I call 180-degree rotational symmetry. To me, that just makes more sense this way. Okay? Do you see anything that has 180-degree rotational symmetry here? A, right? So I'm going to go ahead and use the miracle of smart tools on here. So I go ahead and trace this out. Okay, let's see what happens here. Okay, now, so I have this thing. Isn't that neat? Yes, 180-degree rotational symmetry. But that's, so academic definition, so just look out for that. So this will be odd, right?
Yeah.
Okay, next, ready to go. So what about this one here? Neither. Neither, okay. And then we have 14, determine whether each quadratic function is an even function, answer yes or no. What could you use to help you with this? You could actually use your calculator for this. And I'm looking at this, and I think I know what they are just real fast. Just knowing things. Just thinking about the, yes, Natalie.
I think when you broke my calculator. But I pressed graph and it said error and got like dimension. Pretty good. Did that one get that? Yeah, he did that.
See, this is not dating class, okay? This is algebra 2.
Can you turn it on to me?
Yeah. Goes off.
So what is this one here? A, B, C, D, what are your answers?
No. Determine whether each quadratic function is even function. A is neither.
I don't even know what the negative on my calculator.
What do you think? What do you think, Braden? What do you think this is here? Right.
Come on, Brady. Come on, Brady. Dog.
Kendall, what do you think this is? You have a calculator. Can't you, do you know how to graph these? Do you need help graphing these?
Don't you on the y equals thing?
Yeah, it's called the function editor. You're gonna press the y equals key and you enter the function in. Does anybody have problems entering the functions in here?
Yes.
You do? Which one? Which one, Bryce? Give me one. You gotta give me one so I can do it.
Yay.
Okay? Okay, let's go here. What you do is come up here and I'm gonna go clear these out. I'll press clear, clear. And so I'm gonna put 5x squared. You see that? See that, Bryce?
X squared.
Right, you see that?
And another thing you can do instead of that, let me show you, I'll show you an alternative way to do that. If we go ahead and, I'm gonna go clear this out. You can press 5x to the exponent squared too. You can do it that way too. But then you graph, standard graph, and that's what you see.
I just want to quit.
So that would be a, it's not dating class.
Would that be a no?
What kind of, what is, will this be odd, or will this be an even function here?
Yes.
It'll be even
Yes.
function? Okay, Braden says it's even, I think he's right.
Good job, though.
Chip. Reflects about the y-axis, right?
Yeah.
Even.
Oh.
Oh, it works now.
So what about these other ones?
It's gonna be a kid.
I'd say B is a no, everything else is yes.
So be like yes, no, yes, yes.
Later
Yes,
today.
yes, certainly.
Do you have trouble entering any of these in the calculator?
No, I know how to do it now.
Okay, good. Now, one thing you should do is that you should be over time familiar with this one,
Read the.
with the different types of translations. So, yeah. Okay.
Can you not use that video?
Pardon me?
Nothing.
Use a video.
Don't use a video?
Yes,
Use
don't use
Yes,
the video.
use this video.
Because Bryce said this is a dating class.
It did.
Yes.
Just use it.
Yes.
I like using this class because we have more people in the class than my other classes and a lot of, so it's this class I like, but the problem I have with this class is sometimes we'll make mistakes because I make mistakes. But because it's the first class I have, and I iron out my mistakes by 7th and 8th period sometimes.
But we correct you mostly.
Yeah, most of the time, yeah. So today I don't sense any glaring mistakes so far. Now I might during 7th and 8th period see I did that, but okay.
I don't see any mistakes today.
Okay, now we are to 15 and 16. This is describe how to transform the graph of f of x equals x squared to obtain the graph of the related function g of x. Now, what is this related to that I talked about yesterday? In fact, it was in red that I wrote. What did I write that was in red that I had you take notes on?
I'll tell you, hold on.
The even function.
Even function.
Oh, yesterday.
Yesterday.
Hey.
I don't remember what color he wrote it yesterday.
It was in red, and I didn't write it because it was all rewritten. I just went to the page.
Oh, was it the little?
Was it the little graph thing?
No, it was before that.
How do you?
Okay, what it was the vertex form of
Oh,
quadratic
I told you
function.
that.
Vertex form of quadratic function, right? So this is kind of related to that. How do we, what are the transformations involved here?
I would say
It looks like.
it moves. Just what's it called?
I think there's a Y.
Reflection above the y-axis?
Maybe, no, hold on.
Yes.
Is it Y? Look at me. No,
Yes.
it's definitely x-axis. Yeah.
So, okay, so let's just stop right there. Reflection about the did you say x-axis?
I think that's what it is.
Okay, yeah. All right, so what is it that reflects about the x-axis here? What is it?
It's a negative.
Yeah, so reflects about x-axis. And sometimes it's like the order is important in some of these things. Sometimes you want to reflect last, but I don't think it matters in this case. Okay, so that's what the negative done. Okay, good, Chloe. Somebody else tell what something else does here on this.
It moves to the left.
Moves to the left. What is it that moves to the left?
4.
4, okay, moves 4 left, right?
Yeah.
Okay, good, thank you, Randy. And there's one thing left, this thing right here, what does this thing do?
Would it be the Y interval?
Okay, what you're doing is you're actually, if you pulled this out, this would be like 1/3 times this.
Vertical squeeze or
Yeah, so I would call this a vertical compression
Yeah, that's what I do.
by a factor of 3, okay? So vertical compression by a factor of 3. Or a factor of 1/3, excuse me, I said factor of 3, factor of 1/3, right? So what is that going to look like? Well, you're going to take, I guess before reflecting, we have to see what happens. So we move 4 left, right? Is that right, Randy?
Yes.
So let's go ahead and move our vertex 4 to the left here. 3, 4. Oh, it goes right here, right? There it is. So here's our new vertex, right? And we are reflecting down, so it's gonna go like this, right? And then, but by a factor of 1/3, what does that look like?
Why?
Now you probably don't know, we haven't gone to quadratic functions yet, but what the pattern is for quadratic functions, x, y, is like you have -2, comma, 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, 9, okay? So that's this pattern. But when you go ahead and vertically compress by a factor of 2, what do you have? Factor of 1/3, what do you have to do? Well, you have to multiply all these by 1/3, right? Okay, 1/3, 1/3. So what are those going to equal? 4/3, 1/3, 1/3, 4/3. So that's the pattern we're going to have. So instead of going down 1, we're gonna go down 1/3, right? And 1/3 here, and then the next one would be like 4/3, which is gonna be 4/3, is that like 1 1/3, something like that?
Yeah.
So it's gonna look like this, and then for 9 times 4/3, that's gonna be 9 times 4,
What's it for?
What's it 4/3? Isn't it 1/3?
1/3, excuse me, 1/3, yeah, I was, yeah, thanks, 1/3. So that's gonna be 3, right?
Yep.
Yeah.
So the last one we could do is we go down 3. Okay, 1, 2, 3. So the thing's gonna look like this.
3.
1, 2, 3. 1, 2, 3.
I don't know.
Okay, and then you can put this in a calculator too, right?
How do you do that? Yeah, how do you put?
Let me show you how to do that. What you have is, you have negative 1/3, right?
Why are you in the light short?
So I'm gonna go alpha, so I'm gonna put 1/3, and we're gonna have this one right here, x, and Randy, did you say it was +4, is that what you said it was?
Yeah.
And then we're gonna square this guy right here.
Why this bad one?
And then, I hope this works. Is this gonna work?
Yeah.
Yeah.
Oh, yeah.
Marcus, did that work?
Yes,
Yeah.
sir.
Get down 3. Boom, okay, yeah.
Why is it not so small?
Why is it so small?
Why is it so
Why is
small?
what's missing?
Here's what I want you to do on this one, Bryce. Okay, I want to show you Bryce's calculator here. I want to give you a tip. Okay, look at, okay, Bryce's X and Y axis is not centered, right? So I'm just going to give you a tip on the calculator. If you want things to be centered, what do? Keystrokes. Okay, zoom 6. You press the zoom key, then 6.
Zoom 6.
Takes you back to the standard setting. Start on the top.
Top middle.
Oh,
middle.
6. Oh,
Isn't that good?
yeah, I like it.
What happened is, years ago, I made a DVD that was called Using the Graphing Calculator, Everything You Need, Nothing You Don't. It's a DVD. It had lessons on all this. Okay? Was that helpful?
Yeah.
Well.
And then, yes, and then I think, let's just look at this one more,
One more?
because so we got this g of x equals f of 2x plus 2. What is this going to look like?
Oh, just, isn't it? Be a regular line.
What is this thing going to do here, this 2?
Make you go left.
Make it go left.
Left 2.
Oh, yeah.
Okay, well, this 2 right here is going to do what? Vertically stretch?
Yes.
Yeah.
So we'll say vertical stretch by factor of 2, right? And then what is this other thing going to do, this plus 2 over here?
It's gonna move it to the left. Oh my goodness. What? It's
Gonna move it up on the line.
Move up, yeah. So what it is, here, this one right here, this is what we call it H equals -4. This one here is K equals 2, so on the outside. And so up, so we'll be translating up 2 units, right? So we're gonna we're gonna go ahead and vertically stretch by a factor of 2, which is gonna be like this, 2, 8. So look like this, plus, did you say up 2 units? So this, and we're gonna be up 2 units like this. About like this, right? And if you graph this in the calculator, that's what you saw, right? Now, the thing you got to worry about here is if you go, if you have like, if you put 2x like this, squared, you're going to have like a factor of 4, right? Because that's going to be squared plus 2. So this will be like a factor of 4. I'm going to see what the book has for it. But anyway, that's it. I just want you to keep it there, and let's wipe down our desks, and then we'll go, okay?